In this question, at t equal to 0, a grinding wheel has an angular velocity of 30 radian per second. It's a constant angular acceleration of 26 radian per second square until a circuit breaker trips at 2.4 seconds. And from then on, it turns to an angle of 434 radian as it goes to a stop at the constant angular acceleration. So there's the total angle which is it has moved. That's part A. So from time t equal to 0 to t equal to 2.4, let's find out how much it has moved. So the equation which governs it is, I think we can use the the second equation of motion, that theta is equal to omega naught t plus half alpha t square. Initial angular speed is 30, the time is 2.4 plus half alpha is 26 and then 2.4 whole square over here. So this value comes out as 30 times 2.4 plus zero point 0.5 times 226 times 2.4 square. So this value comes out as 146.88 radian. So the total uh, uh, angular displacement is 146.88, plus in the latter part it is already given as 434 in the question itself. So if we add them up, we are getting 580.88 radians. That is the total angular, what do you call it, as total angular displacement during the complete motion. Then it talks about at what time did it stop. So that's what we have to find. So for that, I think we need to find the, um, because in order to find the time, we should know the alpha in the second case. So let's divide this complete analysis in three parts. One is t equal to 0. This is t equal to 2.4, and this is the time when it stops. Here it is 30 radian per second. This is 26 radian per second squared. Let's say this is omega 1. Let's say this is omega 2. Let's find the value of omega 1. And by the way, theta in this case is given as 434 radians, of course. So let's try to find out the value of omega 1. So omega 1 is omega naught plus alpha t. So omega naught is 30, alpha is 26, the time is 2.4. So this value comes out as 26 times 2.4 plus 30, which is 92.4 radian per second. That is the value of omega 1. So if we know omega 1, then we can find the acceleration in the other case, because the omega 2 is nothing but 0 because it stops. So we use the third equation of motion, that omega 2 square is omega 1 square plus 2 alpha s. Omega 2 is 0, omega 1 is 92.4, alpha is unknown, s is not actually s is theta. Theta is 434. So let me just rearrange. So 0 is equal to, what is 92? Excuse me. 92.4 squared, that's 853, 8537.76, plus this will become 868 alpha. If you rearrange, then minus 8537.76 is 868 alpha, and dividing both sides by 868, the value of alpha from here comes out as minus of 9.84 radian per second square. Again, not something which is asked, but it was required to find out the time. And now we can easily find the time by using first equation of motion, that omega 2 is equal to omega 1 plus alpha t. Omega 2 is 0, omega 1 is 92.4, alpha is minus 9.84, and the time is unknown, which we have to find. So if you rearrange, the 9.84 t is equal to 92.4. So the value of time from here comes out as, over this value is 9.40 second. But this is not the answer, because this is the time after the second stretch. So the total time is going to be this time plus 2.4, which has already been passed. So the total time comes out as 11.79 seconds. Thank you.